So now let's look at the effect of price changes on the optimal consumption bundle. Price changes. So again, let's just draw out our Cartesian plane here with the optimal amount given some prices. And then we're going to change a price and talk about how we can figure out the total change in the quantity of the good whose price changed, as well as decomposing that total change into those two concepts, the income and the substitution effect. And we're going to hopefully give it some intuition about why we're calculating them or why we're showing them the way we are. So let's say here's our Cartesian plane, again, mangoes and fish. Here's our original budget constraint. So let's say that this is budget constraint number 1. Let's say this is point A, so this is the optimal consumption bundle under the original condition. So this is quantity of mangoes in A, quantity of fish in A. Hopefully we can read that. It's just Q superscript M subscript A, or however you want to label them, and then quantity of fish. So I'm putting the good kind of initial in the superscript and then the point in the subscript. So that's the original situation. Let's say the price of fish falls. And so what's going to happen is that, if you remember, we have this kink out of the budget constraint. So this intercept doesn't change, because if we were purchasing all mangoes, we could still afford the same amount of total mangoes. But as soon as we start buying any fish, all of a sudden, because the price went down, the slope is getting flatter, right? So what's happening is that it's kind of fanning out. And so now if we just bought fish, we could afford twice as many, for instance, if the price got cut in half. And so then if we drew indifference curves that maybe look the same shape, I should label these indifference curves. Let's label them I1 and I2. So that was kind of a weird shaped one, but all right, so that means at this point B, this is this new situation with this lower price. We start purchasing more fish and we purchase less mangoes. So the number of mangoes went down, and this is the total change in number of fish after the price change. And so remember, this total change, which is the distance between these 2 points, equals the income effect plus the substitution or the sub effect. And so we need to figure out a way to graphically represent the income and substitution effects. And so remember, the idea behind the substitution effect, we want to hold income or the budget constant and just look at change in quantity of fish, for instance, due to the relative price change. So here, fish are becoming relatively cheaper than they used to be compared to mangoes, right? They used to be, let's say, $4, now they became $2 or whatever they went down to. Well, that means they became relatively cheaper than they used to be. So we know that we're going to substitute towards fish. Remember, the income effect what that's trying to do is capture the fact that because the price of fish went down, our purchasing power went up. So we want to hold relative prices constant. And we want to just look at change in QF in this case due to increase in the purchasing power of our budget. And it's the increase in purchasing power because the price went down. And so how we're going to do this graphically is we're going to take the slope of the new budget constraint. So remember, these budget constraints are like the price ratios. So they're capturing relative prices. And so this green budget constraint here, it's capturing the relative prices after the price change. And so we're going to take this green line and we're going to just slowly move it in, like just a parallel shift down until it just touches the old indifference curve. So we're going to start this new budget constraint, this green one, and in this case we're going to move it in until it just touches the old indifference curve. So it's kind of hard to know exactly, but that's the idea here. And we're going to say, I didn't do that well, but we're going to say it crosses right around there. And we're going to label that point C. So definitely going to hit this line somewhere out here. And so the distance between A and C, so QFC, we can label that. So this horizontal distance right here is how much we changed our consumption of fish just because the slope of the budget constraint changed, just because the relative prices changed. So this is going to be point A to C. This distance here is going to capture the substitution effect. So in this case, I guess we should write the other way. Minus QFA equals the sub effect. So it's the change in consumption just because we're changing the slope of this budget constraint from this purple or pink line to this flat or blue one. So, I mean, this is kind of like a very theoretical or conceptual thing. We don't actually, change the budget line for these for this person. It's just kind of theoretically what it would be. We don't actually see the situation. And then what's left of the total change, remember this distance here is the total change. What's left is C to B, and that's the income effect. So that's what, it's getting really messy, sorry. So that's the income effect. And intuitively it kind of makes sense that it's the income effect because remember a parallel shift out of our budget line is like an increase in income. Well, because these, if I drew them really well and I had a ruler or something, because these blue and green budget constraints have the same slope, this movement from the dotted blue line, this fake kind of budget constraint that we're using here, and the green budget constraint, the one in the new scenario once the price falls, that change in consumption is just like a change, is from a change in income, right? It's just this parallel shift out, that's like a change in income. So that's why it's the income effect. So together these two effects determine the total change. So we're kind of decomposing the distance between A and B into these two different effects. Now, here we can see that the substitution of factors, we're always going to substitute towards the good that became relatively cheaper. So here the substitution effect, C will definitely be to the right of A here for fish. But depending on if the good is normal or inferior, this income change could cause us to increase or decrease our consumption. And remember, Giffen good is when we had an inferior good and the income effect is bigger than the substitution effect. All right, so this is how price changes, or one scenario where price changed resulting in these income and substitution effects. It'd look different if the price went up or if we had an inferior good here.